Bismillahirrahmanirrahim. Today we are going to start our second session of our lecture number 3 in the operating system course. In first session of this lecture, we discuss something about timer, why we need timer and implementation of variable timer and the different type of operating system. Just here we will take a quick overview and then we will move to the second session of our lecture number 3. In first session we said that our first session based on the CLO number 1, which is recognize operating system history, services, application and type, and we discussed timer, and we said a timer is used to interrupt the computer. The timer we can use to interrupt the computer after specified period, after some time. If we want to interrupt the computer, then we use timer, and we have seen the timer this period can be of two types, variable or fixed period or variable period. Then we said why we need timer, because we want to ensure that operating system maintain the control over CPU, because the operating system control over CPU is very important for smooth running of our system. Because sometimes we have given one example that the user program stuck in an infinite loop, so it can create problem. So that's why we must give control back to the operating system. This is very important. Then we have seen that how we can implement the variable timer, implementation of variable timer, and we said that we need two important things to implement the timer: fixed rate clock and counter. So what operating system will do with these two things? These are the two ingredients. Operating system will set the counter. It will give some initial value to the counter. Let's suppose it is counter is equal to 5, and when the clock tick, the counter will be decreases. We will decrement the counter, and when the counter reaches 0, the control will be automatically given back to the operating system. So these are the three steps. We need two things: fixed rate clock and counter. Then we need to do three things to set the counter. Every time the clock tick, the counter is decremented. When the counter reaches 0, timer interrupts the computer and control is automatically transferred to the operating system. Then we have discussed the 5 different type of operating system. We have discussed multitasking and single tasking operating systems, multi-user and single user operating system, distributed operating system, embedded operating system and real-time operating system. So as the name shows, single tasking operating system is allowed to run a single program at a time, but in multitasking system we can execute more than one task at the same time. And which type of multitasking it will be? It can be preemptive or cooperative, and we have seen in preemptive that operating system make the CPU slices, small slices of the time of CPU time, and dedicate one slot to each of the program. But in cooperative multitasking, the program which have the control of the processor, it will retain the control until it give the control voluntarily to another program. So in multi-user operating system and single user operating system, we discussed that in multi-user operating system allow multiple users to access the computer at the same time. So there is a time sharing systems are also multi-user operating system. The objective here it is to share the time. Multi-user operating system is the example of networks of computer. These are multi-user operating system. Multi-user operating system allow many different users to access same data and application program on the same network. It also allows users to communicate with each other. So these are some multi-user operating system that they give us some functionality to perform. Single user operating system that only usable by single user at a time. So examples are our home computer, our office computer, if they are not connected with the network. Then we have discussed distributed operating system, and we said that distributed operating system manage a group of independent computer, and they are linked and they can communicate with each other. So it's not necessary that all the application and data, it must be only on single one computer. Maybe it is distributed around the system on different geographical area, different geographical locations. Then we have discussed the embedded operating systems, and we said that embedded operating systems are designed to operate on small machines like our PDAs, our tablet, our smartphone, etc. These operating systems can operate on limited number of resources. They are very efficient and very compact. Here some example we discuss: C, Windows C, FreeBSD and Minix 3. Then at the end we discuss the real-time operating system. This is also multitasking operating system that the aim is to execute real-time application. So if we want to execute real-time application, so we need real-time operating system, and these real-time operating system use specialized scheduling algorithm. These systems quickly respond to the event and used to control the complex system. So this was our last lecture, first session of lecture number 3. So today we are going to start our second session of lecture number 3. So process. In operating system, process is very important. All the time there are many processes, they are working inside computer. And what is process? So we will discuss. A process is an instance of computer program that is being executed. So we already have discussed that if we want to execute any program, that program must be shifted into the main memory. So when any program is moved to main memory, so it becomes process. So the second point, a program becomes a process when executable files are loaded into the memory, in main memory. When it is loaded, so it becomes process. Operating system have many background tasks running. Your computer is likely to have many more processes running than the actual program. So in operating system, suppose I have executed only one program. Currently I am using PowerPoint, but in backend there will be many processes they are working. So you can check them. If you press Ctrl Alt Del, so this window will appear. So go to the task manager and you will see here all these are processes. See here that many processes they are working on the back end. We are only using PowerPoint, but at the back end many processes are working. So this is the point that it is discussed here, that whenever you are working on if you are using only one software, it does not mean that only one process is working on the back end. There are many processes they are working at the same time. Here it is given one example. For example, that you may have only 3 programs running, but there may be 20 active processes, as we have seen. So how we can check? By press Ctrl Alt Del and click on the task manager. So in task manager you can find the detail about the process and how much CPU they are using, the percentage of CPU they are using, and so on. So again, what is process? Process is instance of a computer program that is being executed. This is actually the program that we have written. When this program is loaded into the memory, it will become process. Okay, so in our system we have 2 types of entities, passive entity and active entity. So what is passive entity? That the file containing list of instructions stored on disk, often called executable file, called passive entity. Everything that we have stored on our hard disk, that is passive. Any program that we have written in any language which is stored on our system, on our hard disk, that is called passive. But the process that we discussed in last slide, that is an active entity. And this process with a program counter specifying the next instruction to execute and a set of resources. So all this is active. So what we understand in this slide, that we have two types of entities in our computer, passive entity and active entity. So what is passive entity? The file containing list of instructions stored on disk. That program that we have written, we store on our hard disk, that is passive. But the process, when those instructions move to the main memory and they become process, so at that time it is active. Okay, so what are the components of process? Process generally include, we discuss, okay, process is instance of computer program, okay, that is being executed. But what are the components? So first thing, we have in each process, that is called process stack. So here, stack, we already know that. Last in first out concept. So this stack contain what? This will contain temporary data, that is, for example, function parameter. Whenever we are passing parameters to function, it will be stored in process stack. Return address, because whenever we are going from one instruction to another instruction and maybe we have to come back to that instruction, so return address, it will also be stored in process stack. And third thing, it is local variables. Okay, so we have in our program two type of variables, global variables and local variables. So all the local variables which will be stored in process stack. So in process stack we have three important things, which is function parameter, return address and local variables. So we are storing these three things. Second part of process is data section. Data section have one thing, that is called global variables. All the global variables we will store in data section. Okay, so local variables, it will be in process stack, but global variables, it will be in data sections. Third part is heap. Heap is a memory that is dynamically allocated during the process runtime. So when we will run our program, so it will be loaded into the memory. So at that time some memory will be allocated to the process, and that memory is called heap. Okay, so last point is text section. Text section is a program code, that is our program, which is sometimes known as text section. Okay, so a process is more than the program code. So we have four components in a process. Our process generally include process stack, data section, heap and text section. Process stack and data section, this is used to store some temporary data and some global variables. So temporary data such as, that is function parameters, return address and local variables. But data section, it contains all the global variables which we are using in our programs. So heap, it is a memory, and this memory is dynamically allocated during the process runtime. When we will run our process, this memory will be allocated. And text section is more than program code. Okay, so the code of our program, that which is called text section. Now you can see this figure that we have stack, we have heap, data and text. So stack, as we said, it contains three things. And what are these three things? That are function parameters, local variables and return address. And what is heap? Heap is a memory which is dynamically allocated to process during runtime. And what is data? Data, it contains all our global variables. And text, this is our program code that we have in our program. Next, whenever we have a process, then process have some states. So at a time, process will be in one state. So currently we have 5 different type of states. So our process will be in one of them. So what are these states? These states are new, we have running, we have waiting, and we have ready, and last one is terminated. As the name shows, it's very simple that new mean a new process is created. So we have created a new process. So process, when a new process is created, so it will be in new state. And then maybe the process is currently in running mode. Means CPU is executing the instructions. So instructions are being executed. So it means CPU is allocated to the process. Then we have waiting. A process is waiting for some event to occur, such as an IO completion or reception of a signal. So is waiting for some event to occur. So in ready, the process is waiting to assign to a processor. Process is assigned to a processor. Terminated, the process is finished. Okay. So these are the 5 states that process will be in one of them. If you go next slide and see, this is process state diagram. So here a new process is created, and this process after creation it will be admitted to ready state. So ready state, you are going to ready state after new process is created. It means this process is ready for execution but waiting to move from ready state to running state. Okay. So from ready state, there will be scheduler who will pick the process and it will move to the move to the running state. Now scheduler or dispatcher, we will discuss in coming lectures what is this scheduler or dispatcher. So this scheduler will pick one process, because maybe in ready state we say this is a one queue, and in this queue we have many processes. Suppose I say this is P1, we have another process which is P2, another process which is P3. Suppose we have 3 processes, they are ready for execution. So P1, P2, P3. So we have to move only one process from ready state to running state. So we need to select which process we move. It's not that we move all these 3 processes. So we have to select one process from this queue. So scheduler, it will make a decision. We have some algorithms to execute the process. So we will use those algorithms. We will discuss those algorithms in coming lectures. But here that basic concept that from P1, P2, P3 we have 3 processes here. So we need to select one process and we need to move to the running state. And who will do this? Scheduler. It will do this. Okay. Then after this, our process will be here. Suppose he has given P2. P2 is now here. Okay. P2 is removed from here. It is removed, and now here we have only P1, P3, and now P2 is here. It is in running. It means currently processor is executing the instructions which are given in process P2. Now there are 3 possibilities from here. Maybe this P2 finishes work and it exit and terminate it, exit from running state, or maybe it is interrupted and go back to the ready state. Interrupt, if you remember, we have seen interrupt and we have seen 5 type of interrupt. So interrupt, maybe the time slice is expired by using preemptive approach. Time slices expire and it go back to the ready state. Or the third possibility is maybe it is waiting for some IO device, or maybe it's waiting for some event and it is moving to the waiting state. And this is third possibility, when the process is in running state and maybe this process exit or interrupt came and it can go back to ready state, or it can move to the waiting state. Okay, so now if we say it is going to the waiting state, and when his wait will finish, mean maybe he is requesting for IO device and he get the IO device, then he again go back to the ready state. Okay, and here you can see the cycle. From waiting, it is not possible directly we go to the running state. This is wrong. It is not possible. And maybe the question in exam, that is, it is possible to move a process from waiting state to running state directly. Okay, so we have to follow the path from waiting. When his request, IO request, will be completed, that resource is assigned to him, then it will move to the ready state, and then from ready again the dispatcher or scheduler, it will move from ready to running state. Okay, so this is the cycle that we are going to use. So we have 5 different type of state: new, ready, running, waiting, and termination. So this was our second session of our lecture number 3. So we will just take a quick overview what we have discussed today. We started our discussion with a process, and we said, what is process? Process is instance of a computer program that is being executed. So the instance of a computer program that we are going to execute, this is called process. Okay, now we will discuss that one process may be divided into small subparts, and that is called thread. So this is our next lecture. We will discuss that how. So a program may be divided into many processes. It depends on the size of the program, how much is the size, and how it is working. But a process is an instance of a computer program that is being executed, that we are going to execute. Okay, so when a program become process, when a program is loaded to the memory. When a program we are loading in the memory, then it will become process. So at a time, whenever we are executing, suppose one process or two processes, on the back end, many background tasks are running. And tasks, these are the processes. As we have seen by using Ctrl-Alt-Del, if we press and we check the task manager, you will see many processes, they are working on the back end. Okay, now we have discussed the passive entity and active entity. So passive entity is the instruction which are stored on the disk. These are passive. And what is the active? The process. Process is an active entity. When the program is loaded into the memory, it becomes process. So now it is active. But when the same program is on hard disk, it is stored on the hard disk, at that time it is passive. In our hard disk we have many things. We have different lectures, we have books, and we have maybe movies, songs, and many things. But all these things are passive. But when we select one and we bring this into the main memory, and then it becomes active. So we have passive entity and we have active entity. Then we discuss the component of a process. Process includes process stack, data section, heap, and text section. And process stack contain 3 things, that is function parameters, return address, and local variables. And data section contain all the global variables. And heap is a memory that is assigned dynamically during runtime of process. So when we run our process, the memory is assigned at that time, which is called heap. And text section is a program code. Okay, So these are process include these four things, and then we have seen the 5 states of the process, that is new, running, waiting, ready, and termination. So this diagram shows new process is created, then from it is moved to the ready state, and from ready state process can move to running state. This is the only one way, that from ready it can move to running state. It is not possible that from ready process go to the waiting. No, this is also wrong. This is not possible. Okay, so there is a problem. It should be, it go from ready to running state, and from running, no, there are 3 possibilities. That process can go to the waiting state, it can go back to the ready state when if interrupt occur, or when it complete his execution may be terminated. Okay, so these are the 5 state diagram, 5 states. In the process will be in one of them. So if you have any question, you can send me email on my email address, or you can visit my office during my office hours for any suggestion, any question. Okay, thank you very much, and see you in next lecture.